Hi, everybody. Thanks so much for having us. Such a pleasure to be here today with these two fine folks. I'm Jordan Valdez, VP of Communications at Stability AI. I'm joined by my colleagues.
All right, my name is Joe Penna, VP of Applied Machine Learning at Stability.
And I'm Robin. I'm leading a small research team in the Black Forest in Germany.
So, guys, let's start out by talking about what everyone in this room knows to be true. AI is the hottest field in the industry at this moment, and folks from all walks of life are bringing their diversity of experience to the fore to create the best technologies. Tell us about what you were doing before and how that led you to Stability.
Yeah, so my trajectory is rather classical, not as fancy as Joe's, but yeah, I started with studying physics, actually, so I wasn't too much into AI before. Actually, I didn't like programming that much in the beginning. I wanted to do theoretical physics, but then during studying physics, I realized, oh, you actually have to run simulations, and these simulations give you really nice output sometimes. You have like nice pattern formation. I got into classic generative art that's based on cellular automata. I did my bachelor thesis in this area, and that got me into like this, in this whole field of pattern formation, into AI. There were a lot of AI courses actually at our university in Heidelberg, and that got me interested. I started my master thesis in the computer vision group in Heidelberg, where a lot of great people actually already worked. And I started with actually what we are doing today, but on a much smaller scale, like generating images, but like 32 by 32 pixels or 64 by 64, very blurry, very, like, definitely not at the level of quality that we have today. And I did my PhD in that field and tried to improve these models. Maybe we can talk about this later, how exactly that works. But yeah, now I work at Stability. As I said, we have this research team in Germany and also distributed across the world. And we are trying to make these models really good at a general level. So just entering any text that you want, producing an image or video of that text. And we are trying to make these models better, safer, and also faster.
That's awesome. Yeah, so I took a slightly different turn than you. I was going to be a doctor, and I decided that I should be definitely nowhere near a scalpel in my whole life. So instead, I decided to try to do YouTube back when it was like 2006, 2007. Nobody even knew what it was, but I got it started then, and yeah, grew my channel to have 500 million views, 3 million subscribers. They kept coming back and back and back. Out of that, I started doing music videos, commercials, and then eventually I got into feature films. And yeah, I started directing, writing, and eventually producing these features, mostly indie feature films. And yeah, this crazy thing came out on the internet called Stable Diffusion, and I'm like, how does this work? What, like a text image? Like that's really, I could use this for my job. And I started reading into it, and I almost didn't believe it. Every explanation that said it starts from literally random, colorful pixels. Just completely random pixels, and it looks at your text prompt and starts moving the pixels around. Looks at literally, oh, okay, it's asking for a cat, so maybe these pixels kind of look like a cat wearing a hat. Oh, I got to put a hat on top of that cat. So I'm like, that's not possible. That's not possible that computers can do this, because if it is, maybe they can one day do something that's helpful for me as a filmmaker. So I kind of got obsessed with it to the point where now I'm here.
Obsession is great.
It's
what it takes to be successful in any field, right? So Stability is one of the leading independent, open, and multimodal companies in the industry, but most people know it for its flagship product, which is Stable Diffusion. Tell us about Stable Diffusion. How did that happen? And how far has it come as a technology?
Yeah, so maybe one important thing to note about Stable Diffusion is how it is different from other approaches, other diffusion models that are around. I mean, we're not the only ones who produce them. So what makes it special is that it is a so-called latent diffusion model, and that's something that a lot of our research team members and we developed while we were still at the university. And basically the idea is you want to train these very general text-to-image models. And to do that, you have to train on billions of images, actually. And images, especially if you want to generate high-quality, high-resolution images, they are extremely high-dimensional. They're very expensive in a computational sense. So we have to come up with algorithms that can actually do this training on billions of images very efficiently. And what latent diffusion does is it takes these images and compresses them into a computationally more feasible representation, actually. And the other important part to know is that images contain a lot of redundant information. That's why image compression works so well. And if you would just train a generative model on high-resolution images directly, your model would need to learn to simulate or to generate all of these high-frequency details that in the end, as a human observer, you don't really perceive. So that's also what latent diffusion achieves. It compresses these high-frequency details that we don't really see anyways. It compresses them away, and it makes the task for the generative model easier. And that you have that compressed representation, and you train the diffusion model, the generative model, on top of that representation, and that really helps to get an efficient, fast generative model.
Yeah, kind of crazy.
It's incredible.
Yeah.
So when you're talking about these generative models, there's so many different applications, so many different real-world contexts. How do you evaluate them? Like, how do you know that the model is doing its job? What metrics do you consider when you're thinking about rating its functionality?
It's definitely something that we started to talk about. You had done Stable Diffusion, and when I came in, we started talking about the next level of things. Like, my entire team is, you have all the PhDs and all the brainiacs over there. My people are just obsessed with this, right? Like, that's my crew. And we're like just constantly thinking about it in the shower and constantly thinking about, like, I'm going to be doing this, I'm going to be doing that. And it's like, my wife every once in a while is like, well, what do you think about for dinner? And I'm like, no, but if we condition on size, I think that she's like, just Alfredo it is. So, like, we started thinking about, okay, what can make these images better? And what are these kinds of metrics that you're talking about? Because historically, there have been some things like FID, for example, clip similarity. These are all like technical things that say, oh, this model is really great. But does that really make a wonderful image? Does that make something that's like exciting, something that's different, something that's surprising? Maybe not necessarily so, right? If you're just making the thing that you would expect out of that prompt, right? And then one problem that we were seeing with a lot of these generative models that were very, very good is that maybe you can't get the same character. You can't get like, I asked for an orange T-shirt and not a person holding an orange, which is a hard thing for these things to get. So, yeah, we started to look at and really evaluate these metrics and started to see, like, oh, we have to change completely the architecture of the model in order for these metrics to start to make sense and to align a little bit more with human preferences, right?
Yeah, and maybe one other problem that we had, like when we first launched the first versions of Stable Diffusion, usually what you do to train these models, you crop the images such that they all have the same size. And that sometimes gives you images during training where like there's a portrait or like a picture of a human where the head is cut off, for example. And if you do that, then the model learns to generate these images as well, but that's not like an application that you want in the end. So one thing that we try to improve is actually avoiding that. And there are multiple things that you can do. You can either not crop the images and train on multiple resolutions at the same time. Another thing that we introduced is that it's more like a technical thing, but you actually condition the model on how much you cropped away, and then you can, when you want to generate something, you can just tell the model, don't crop anything, and that avoids this problem. It's something that we introduced with the recent model SDXL, so that's our recent version of Stable Diffusion, kind of. And actually, it has a worse FID, so this metric that we use to evaluate and develop these generative models, it has a worse FID than the first version of Stable Diffusion, but it looks much better.
Yeah. really wanted to make sure that Stable Diffusion XL, before we released it, was better than any other open source model, because people had started to take Stable Diffusion and make some amazing, like, fine tunes of it that were realistic or anime or whatever it may be. And some just amazing like work that they were doing on themselves, by themselves, on their own compute. So we said, let's really make sure that this is the best model so that everyone can switch over to that. And yeah, so we we ended up making some of the metrics that are classical metrics for these models kind of worse, but everyone agrees. With our voting, we can see we've done like so much testing. It's a much better model.
You know, you mentioned the voting, and I think that's something that's really interesting about open and interesting about what we do in particular. Can you talk just a little bit more about that part of it and how we tap into the AI community to even help us do that better?
Yeah, absolutely. You know, and it's a little bit of that I'm talking about. Like my whole team is part of that community, comes from that community, right? It's because it's the people who are actually using the models that we're building. They're the artists, they're creatives, they're you know, we have to make sure that there's certain metrics that we're hitting in terms of these things that we're talking about. Like it needs to be like this kind of size, it needs to be like these kinds of images, it needs to be done in this kind of amount of time. But then when you start hearing about like how people are using these models, that's when it starts to like really like make sense why we keep doing this and why we're like kind of like obsessed with pushing it forward. You know, you keep hearing some stories. For example, there's an artist that she had lost the mobility on her hands, right? And she used to draw these beautiful comics. So her husband scanned them all in, sent them to us, and said, "Is there anything you can do?" So we fine-tuned a model for her, and now she can use her voice to make her comics again. You know, it's like that kind of application that I think is, and like that's just one of so many stories that are like that. That it's just it makes it worth it for us, you know, to keep pushing these models to be better and better and to have a clear understanding.
And I think it's actually a really cool perspective to have like non-researchers actually work with these models, because we were used to improving certain metrics, beating existing methods, and such that we can publish a paper. But right now, the stuff is at a level of quality where we can't really use this anymore, and you really need input from people from the creative industry who evaluate these models, or like from users of the models. So that's a really helpful signal.
Who cares about papers, right? Now, that being said, as soon as he put me on a paper, I sent it to my dad. I'm like, "Dad, I'm on a research paper."
What did he say? I'm sure he loved it.
Oh, he's like, I don't understand any of this. I'm like, me neither, but that's okay. It looks pretty.
I want to go back to something that you said a little bit earlier in the conversation. You know, the process of developing a model is an iterative one, right? And it involves some planning, some trial and error, some magic, and maybe a little bit of surprise too. What surprised you most as you were thinking about building this model, and what is something that maybe would surprise our guests here who've come to learn about him?
So what I find really surprising, actually, is that these models, Stable Diffusion, for example, it's not just a text-to-image generator. It has, like, by training on these millions, billions of images, you actually capture real-world understanding of objects that are present in the images. So, for example, you can use a pre-trained Stable Diffusion model or another text-to-image diffusion model, and you can use it to generate 3D representations of a scene. So there's a method that's called score distillation, which does exactly that. It optimizes a 3D representation, for example, a nerve, and evaluates that with a diffusion model. So that's super cool that this actually works. There are other things. You can extract stuff like depth information or object detection from a pre-trained text-to-image model, which really shows that it's more than just useful for generating images. And yeah, that's I think one of the most exciting directions also for future explorations, because it shows that you can actually train on images. We have lots of images available, but then you can maybe transfer this to another data modality for which you don't have that many data points available. And leveraging that is a really exciting direction for future research.
Yeah, it's surprising. You know, when you start thinking about like, oh, it just like it learned some images or something. But that's not the case. It has made these connections about our world. Like by looking at these images. We never taught it this, but it learned depth. It learned like what certain English words and Spanish words, and we keep being surprised. We're like, oh, what happens if we just try this? What happens if we try that? And can it learn this? Can it learn that? For example, people have used Stable Diffusion to colorize old photographs, right? And it's an amazing colorization technique, right? People use Stable Diffusion, even like one of the craziest things I've ever seen is using EEGs to show people some images, right? You fine-tune the model on that so that it understands. And it's like, all right, think of any image right now. And then Stable Diffusion makes the image that the person's thinking of at that moment. It's crazy to me, right? It's like we have this base model, and we're like one step away from all of these crazy, like insane applications that we can make that happen. And so releasing the model open source allows people to try those things because we don't have the time to try. I don't know about you, but I don't have an EEG. So like being able to release this so that others can try it is amazing. That being said, there are some things that are surprising about it, that they don't think like us, really. I like to humanize them all a little too much sometimes. He's like, it's just the code, man. I'm like, but there's, but think about it, right? Like it's thinking about it in this way. Like if I were to ask you, like what's the opposite of a puppy, for example? What would you say?
A kitty.
A kitten, right? You ask Stable Diffusion what the opposite of a puppy is, and it gives you a drone shot of a Floridian cul-de-sac with like perfectly manicured lawn. And I'm like, well, my opposite's code, it must be broken or something. And then I go away and I'm like, no, like a kitten and a puppy, those are identical.
Very similar.
Those are very,
Yeah.
the images are almost identical.
Yeah.
So it doesn't think like us in some ways, but it very much thinks like us and understands what we are in other ways, which is interesting.
It's so interesting.
Yeah.
And it's also very experimental, right?
is.
Because if we're iterating to get something right, it means we're trying it, and then we're testing it, and then we're fine-tuning it. All of this is an experiment, really. Tell us a little bit about what the future might look like. I mean, I know it's not easy to say because we're experimenting, but what are some elements of what the future holds?
So yeah, fine-tuning is one application that's super popular right now, but that means that you actually have to train, or like fine-tuning means you have to train for a few steps, and that's something you have to do. But maybe that's something that we want to avoid and actually want to make these models, give these models the ability to adapt to like new user input in a zero-shot manner. So I think this is something that's developing and something for the future. Then of course the other thing is that you can actually use that that fact that these models are kind of a rendering engine, use the knowledge and, for example, turn a image generation model into a 3D generation model or into a video generation model. Also expanding to more dimensionalities to just image. Obviously, video models are also kind of hyped right now. Improving video models, making them go from like 2 seconds to actually 30 seconds and then to a few minutes. I think this is like a super challenging task for which we need to develop new methods. And the same for 3D, like generating high quality natural 3D assets is also a very difficult task if you don't want to do it based on optimization, which is kind of slow, but same actually as for the text image models where you do it in a feed forward, a fast way. So yeah, expanding into new dimensionalities maybe, and personalization.
Yeah. That's what I'm excited about the most, is the personalization aspect of it. Because when you have a model that can generate an image like that, that changes the way that stories are told. Mm-hmm. And stories to me is not only films or a story that you tell your kid at night or something. Like an old photo that needs to be colorized. There's a story in that picture. Mm-hmm. Mm-hmm. There's a story behind just like an ad as you're scrolling through Instagram. There's always a story behind every visual piece of information that we get to, whether that's a video or whether that's a little 3D asset or whatever it may be. Growing up in Brazil, I would watch movies that were translated into Portuguese, and dubbed, and they just kind of felt like there was like one little thing away from where I was. It's like, this is just like some thing that doesn't understand me. Until I watched one movie in Brazil where there was a global destruction, and there was like Christ the Redeemer, like for one single second, crumbling, and I said, I almost started crying. I'm like, look, they're thinking of us. I'm so glad that they're destroying our country too, in this movie. And it made me realize that like that level of personalization is going to become possible with technologies like SDXL and these video models and like these personalized models that are going to start becoming more and more understanding of who we are and what we want.
Yeah. Yeah. And so, what I guess the obvious, final question is, what does it take in order to get us from here to there? So are we headed toward a world where everyone has their own AI?
I'm going to have to step in and leave the cliffhanger of a question of where we're heading to give a massive round of applause and thank you to Robin, Joe, and Jordan from Stability AI. Thank you all so very much.